So we are done with this. Now we have to talk about this. Okay. We have all heard the term in chemistry.
Sure.
What is enthalpy of formation? Nick, you said something yesterday.
H.
Good. Is that it? And how do you find that in chemistry? It's given. They're given a bunch of numbers. Excellent. So chemistry books tell you H is a bunch of numbers. And this is the H that is for each mole of water produced. Have you ever wondered where these numbers come from? So the next time when you think of these numbers, I want you to think of this person. What is this person doing? Creating a rabbit out of nothing. The next time you think of enthalpy, I want you to think of this picture. This picture represents a magician creating a rabbit out of thin air. So what does the rabbit need to do in order to create the rabbit?
The rabbit doesn't need anything.
Well, he needs enough energy to create the rabbit. And then what does he have to do with the atmosphere that was already there?
It has to go somewhere.
It has to displace that atmosphere, right? That's what enthalpy is. In your system, you not only have to create the original, but you also have to move the atmosphere away to make room for the rabbit that you just created. So how do we write enthalpy then? Enthalpy is by definition the energy required to create your system plus PV that is required to move the atmosphere away. So pause for a second. Think about what I just said. Enthalpy is energy, the original energy that we've been working with. What was the original energy definition? Guys, do you remember? What was first law? Q plus W? You guys should remember that now forever. If I say first law, what should come to your mind? Q plus W equals delta U. So enthalpy is adding more to U. It is the energy, it is the U original plus the work required to move the atmosphere away. Okay? So we are going, do you want me to write that down or will you remember? Now look at the picture again. Does that make sense now? So the delta U of the rabbit or the U of the rabbit plus how much work is done to move the atmosphere away. Okay, now this is to create the rabbit, but magicians also do what?
Destroy that.
Right? Destroy the rabbit. So when they destroy the, wow, God, that's a bad analogy. I don't know. Okay, But in order to annihilate the rabbit, what do you need to do? One, gain the energy back from the system, right? Gain the energy back from the system. Plus, what happens to the room left over by the rabbit when it disappears? The atmosphere has to collapse onto itself, right? So both cases are going to be true. And what do we call reactions generally? Exothermic and
Endothermic.
have you ever wondered why?
No.
Because in one case you are creating heat, and in the other case you're putting in heat to cause the system to actually work. Okay, so why is enthalpy useful? Because I said so. Oh, I like that answer. Can we keep that as a standard answer?
What?
For everything? Because I said so?
What's the answer?
He said, I said, what is the usefulness of entropy? And he said, because you said so. Yes.
Can we use that on an exam?
No.
Then we can't keep it. Then we can't keep it. Then we can't keep it.
You can use it after you've solved it. So why is it useful? When how do I say this? Okay. Suppose we have a constant pressure system, and say we add heat to it. What will happen? According to the first law, it could, in fact, result in, number one, change in internal energy. Number two, it could also change its volume. And number three, it could change its enthalpy. Can I call that change in enthalpy delta H? So then will my system be written as H that was there plus delta H? So remember delta H was U plus PV, correct? So then may I write this as U plus P atmosphere V plus the change delta U plus P delta V. So does that mean I can rewrite this as H plus delta U plus P ATM delta V, or these two go away and delta H will be left to be delta U plus P ATM and the change in volume where it is possible. Okay, what is this equation saying to us? This equation is saying that enthalpy can change under two conditions. One is when energy changes, and two, when the system expands or contracts. When the system expands, work must be done on the atmosphere to make room for it. When the system contracts, atmosphere does the work. to take over the space. Okay, are we good? What would you like to call this equation? So we had a butterfly first. Can I do flower? I can. Can I make a prettier flower?
To a sword.
There we go. So the question was, what happened to my Q? It still resides in here. So then may I rewrite this equation, the flower equation, to show you what happened with my Q? So did I write this? The Q still lives inside here. May I write this as Q plus P delta V plus any other work that's done on the system? Oh no, it'll be minus, right? This will be minus. Plus P ATM delta V. Do you know where that minus is coming from, right? Because we defined work as negative PdV. May I cancel these two? So now my new definition of delta H in terms of heat is W other. And what is W other? Any other kind of work done on the system or by the system, on/by the system. And what is this kind of work or that kind of work? Our standard compression expansion works. Compression expansion work. Okay. Now I want you to be awed by this. This is going to be fun. Maybe not. It's just, it was fun for me the first time I realized it. Can I write delta H over delta T? Can I do that? Can I also write this as dH over dt? May I also write this as partial H over partial T at a constant pressure? May I rewrite this as partial over partial T of U plus P partial U at a constant pressure equals, may I rewrite this as that? That's my U. Partial V over partial T, P is a constant. Have you seen this before somewhere? Look at your notes from last time. What was it called?
CP.
What was CP? Capital C?
Capital C. Capacitance.
So what does that tell you? The first time I realized this, I was like awed. I was like, this is so cool. This is the same exact thing. Nothing new. Wait, what? That's it. Heat capacity is fundamentally delta H over delta T. That's it. No matter how fancy these equations are written, no matter how complicated the issue is made, it is just as simple. Okay, now, I said something about exothermic and endothermic reactions. What is an exothermic reaction?
You didn't tell me.
And what is an endothermic reaction?
Come on, teacher.
Heat does what? Heat does what?
Same.
So heat comes out in exothermic
You keep your skin pretty good.
and heat goes in for endothermic. So what do you think delta H does? So for an exothermic reaction,